Be prepared to have to develop around your core product to help your customer implement your technology. Don't expect them to do all the legwork for you. Help them to get your product to market, because you're on that journey with them, and you share a mutual benefit in being successful. Don't just expect them to work it out on their own.
Welcome to the Lab to Market Leadership Podcast. Too many advanced science and engineering companies fail to deliver their innovations from the lab to the market. We are on a mission to change that. My name is Chris Reichhelm, and I'm the founder and CEO of Deep Tech Leaders. Each week, we speak with some of the world's leading entrepreneurs, investors, corporates, and policymakers about what it takes to succeed on the lab to market journey. Join us. When do you start thinking about engineering and scale-up? And when is it the right time to bring on board a scale-up and engineering lead? That's what this week's podcast is about. My guest is Tony Pearce, one of the UK's leading semiconductor and materials scale-up and engineering executives. And he's going to talk through with us his current time at Paragraf, where he is COO, responsible for their scale-up engineering and production. He's going to talk through the early days, going to hopefully talk through the dynamic of the early team, how they settled on commercializable and manufacturable routes to progress, and talk through the general challenges and milestones that have to be considered as you take a materials or semiconductor company from lab to market. I hope you enjoy the podcast. Tony, thank you so much for joining me today.
Thanks for inviting me in.
I am delighted that we're getting the chance to have this discussion. I want to jump right into it. Let's say I'm an entrepreneur and I'm setting up a company I'm setting up a young materials or a semiconductor company. I've got some ideas, and I've been working on these ideas for, let's say, 5 years, maybe even 10 years. And I've got my ideas now, and I want to incorporate a company, and I'm going to raise a little bit of finance. At what point should I start thinking about bringing in someone who can help me consider the scale-up and engineering aspects of what I'm doing?
Well, you can expect me to say straight away, Chris. See, COO is a great value for money. You should hire them right at the beginning. I mean,
Yeah.
This is probably where sort of hard tech businesses differ from software or services or something like that, where you're physically manufacturing something. You need to put together the infrastructure and the processes to get into manufacturing something yourself within your own four walls.
Mm.
And that is often a step which, for somebody that's been working in academia or research environment for a long time, is both daunting, but most significantly, it's different. And you have different considerations. So when you're researching something, most of these great discoveries are born out of a sort of controlled chaos, if you like. There's what you want to happen in a lab is variability. You thrive on that. You want to be looking at how various material properties, in our case, react to changes in conditions. In manufacturing, you want the complete opposite. You want everything the same. You need to be repeatability. You don't want a sort of a wheel of fortune effect on the output that you don't know what you're going to get until you've done it 20 times and get 20 different results, which is great if you're investigating that variability and understanding the process, but is no good for manufacturing. So having somebody on the within that group relatively early on, not to burden the organization necessarily with big corporate operational sort of overhead, but to think about how are we going to manufacture this product further down the line? What is the
Yeah.
sensible way to move forward? I mean,
And at that stage, though, you might not even have a product. I mean, you just
no.
might have. So if you're thinking, if we're thinking about the very early stages here, we've got a material, or we have a process. We have a
Mhm,
process for
mhm.
depositing a particular material on various substrates and increasing their performance quite dramatically. And so if we, you know, this works at a particular scale, at maybe
Yeah,
the gram scale in a lab, but there's nothing to say it's going to work when we try to scale that. There's nothing to say that the unit economics are going to work, or we're going to have a bill of materials that's remotely possible to obtain for,
sure.
again, within a set of unit economics, or for geopolitical reasons, or for other things to do with supply chain, or their potential quality performance issues, whatever it is. There are all sorts of different things that could go wrong. So
Right.
is there a way of balancing out some of that early wonderful innovative research with some reality too? And what
Yeah.
does that dynamic have to be like?
Yeah, yeah. I mean, you have to do that. If you think in Paragraf's case with Graphene, I mean, Paragraf's whole existence as a company is on the back of this very issue. Is that
Yeah.
if you think graphene was discovered 20 years ago now,
Mm.
and when Professors Gaiman and Orsula um, did that discovery in the University of Manchester, famously with a piece of sticky tape and a block of graphite, the usual experimental apparatus. Um, it was a great discovery. It earned them the Nobel Prize further down the
Yeah.
line for the significance of that. I mean, there's no Nobel Prize for manufacturing, and therefore
Mm.
the that incredible discovery unlocked a whole load of research into that area, into that material system, into the potential benefits it brings to a whole host of areas. And in our case, the most interested in electronics. But there appeared to be sort of a path of discovering how the material can be used at prototype stage, or making great discoveries to write papers with, but not necessarily what the industry struggled with is how to manufacture it. And
Yeah.
Paragraf hit that issue head on. Rather than looking at the product first, it was born out of needing to find a manufacturable process. So in a way, that issue was right at the heart of Paragraf's creation, is to look at how to take a scientific discovery from
Yeah.
the academic realm and into manufacturing.
And you
And
were in
and
there quite early, weren't you?
yeah, the company was a year and a half
Yeah.
from spin out, and the team when I joined did a fantastic job of bringing that science out of the lab environment and into the first premises. And when I walked in the door there the first time, it was incredibly impressive to see at that stage on a modest scale in the early days what was sort of inside the behind the door in the first facility that had been done on a modest budget. So
Yeah.
there's a spin out, but it was
Where were they in
already
terms
at
of
the
technology
beginnings.
progress?
Uh, from a from the process, the being able to create, the core IP had moved on really well.
Mm.
What was it? Was at the early stages was the productization, if that's the best way
Hmm.
to describe it.
Hmm.
And there was the beginnings of the first demonstrator product,
Hmm.
which I think at that stage, 1-2 years in, we probably believed it was closer to market readiness than it really was, because you learn as you go on, and you look back at it. There was a lot we didn't know.
Yeah.
Um,
So would this
but
have been like a TRL5, or was this a
yeah,
TRL6?
yeah,
If you had to put it into those.
yeah. From a product point of view, yeah, early 5.
Yeah. Yeah,
But
yeah, yeah.
and I think we had uh, we knew and saw the properties of how graphene can transform the performance of a device. Um, And in those early days, it was trying to get the repeatability, to make sure that we could both improve material quality, but do it every time. And do it, and many of the sort of leadership team in Paragraf are coming from that semiconductor background, not just myself.
Yes.
And that means we understand what the industry is looking for and what it needs, and therefore we're looking at it from that angle rather than trying to publish headline results that would ultimately, lead to either unrealistic expectations or issues further down the line.
Now you have a tremendous amount of experience in scaling up semiconductor companies and processes and materials and so on. Is there a particular dynamic that you think needs to be in place at the very early stages between, let's say, the product or market focused part of a business, the technology part of the business, and then the scale up and engineering part of the business? Those are the ways I kind of think of it. The commercial angle, the technology angle, and the scale up angle. Is there a dynamic that has to be there, you think?
There is. There is. I mean, that actually is a part that I think I probably learned the most from my time with Paragraf, because I've been lucky enough to be part of a number of situations in larger companies where we've gone through some very aggressive scale ups and ramp ups, but within organizations that are already a little bit more established or have been through a previous ramp before with a different product. And in that case, much of your the relationships within the different departments, the infrastructure, the internal workings of the businesses is already in place. But when you're doing that in a startup environment, you need to be incredibly well aligned at the individual level, not from the commercial customer facing end, the research lead, and manufacturing operations. And in our case, we sat around in the same room, in the same table. And we were part of each other's conversations every day. And at the earliest parts, while COVID got in the way of that a little bit in terms of our ability to all be in the same room all of the time. But the importance of that alignment was really important. You don't have that at the beginning, then what happens? Commercial will be trying to go down a route of commercializing something we can't make. Technology will be making things we can't sell, and manufacturing will be making the easiest thing possible, right? So you have to put that triangle needs to be somewhere in the middle that we are we're aligned all the way through, and we understand what the customer base needs, and are not wasting time.
Do you think that demands of everyone a finer appreciation of first principles? The fundamentals that kind of underpin in the technology sense, in order to be able to start scaling something from the smallest piece, if you like, the smallest stage, the smallest scale. Do we need more of an understanding of kind of first principles? Then, for example, you need, when you've already done it, let's say at the ton scale, and now you need to go to multi-ton scale.
There is. I mean, we some of the principles and the way that we've gone about going through those decision-making processes, or making sure that we've considered all of the various aspects and don't get caught out by surprise when we get sort of close to prototype, is to actually put in place some structure around new product introduction. And a lot of companies have NPI, established NPI processes, and they can be quite an overhead, certainly in larger organizations. But by stripping that down to quite a light set of requirements for the different, you might call them product readiness levels, I guess, or going from initial sort of commercial understanding, market understanding, through to sort of readiness for production. We sort of honed in around some discipline around that, so that we don't develop down a dead end, or certainly at the pace of which there's technological change. you start off developing something that by the time it's ready, the market's moved.
Yeah.
So there's some discipline required, but across the organization, from commercial through to production,
Yes.
aligning around something like that.
Yes. The approaches and trying out, within Paragraf, for example, did you guys get it right first time in terms of your approach, or did you have to kind of iterate a few times? And was there a system
iteration
for that?
I think we developed a system for that as we realized we needed it. I think and I think that comes down to the way that, in Paragraf's case, how the business evolved, in that it was born from a process capability to be able to deposit graphene directly on substrate, something that nobody else could and still can do.
Yeah.
And that meant that we were applying that to areas where we believe graphene could have the biggest impact in electronics, but also with an angle that, let's not bite off too much more than we can chew in the first step. Let's not go straight for trying to create a processor or a logic chip. Let's look at something which is a demonstrator technology at the beginning, and we homed in on the magnetic sensing area and what is under the skin a Hall cross, which in electronics is pretty much the simplest device architecture you can home in on. But
how long did it take you to get to
that? We had the first product within a couple of years. When the beginnings of the product was there before I started, there was already work towards what was the first iteration. But to your point about how we iterated it, I think what happened is we were materials engineers, scientists. We were from a semiconductor background, but when you look at the use cases for magnetic sensing, it's everything from high physics laboratories to and cryogenics through to some of the markets we're looking at now around automotive, battery manufacturing, and so on. At the beginning, none of us in the organization were experts in those markets. And that meant that the first iterations of the product, you risk them being either what it is you can make, which isn't necessarily what the market is looking for, or what we think the market wants, from a position of relative naivety compared to the people that you're speaking to. So the steep learning curve in terms of, okay, we know how revolutionary the technology is. We know the differences and what performance this technology can bring, but how does that materialize in the real world? What are the pain points that the customer really has where this product can have an impact? And then you redesign, in some cases, or modify the product, be it the size, footprint, the performance, that you tune it to that particular market. So it went through a few iterations on that basis, and now that simple product has created 4 or 5 different flavors, because we've realized that what is good for quantum computing, measuring at millikelvin temperatures, for example, which is one of the unique performance areas for graphene, is a different product to what may be being used in battery manufacturing, where you're using it as a current sensor for detecting very small leakage currents, and in that use case, sort of trying to prevent battery fires by detecting very small leakage currents. Those two products are different, and therefore we've only found that out through bringing in people that were knowledgeable in those areas, product experts, and gaining that experience, so that we honed in on that. So some companies, of course, have that already on board. They may be developing a product where they are already the expert in that particular product area, and that isn't an issue. From our perspective, we have a platform which we're applying to different places, and that means you're not necessarily from the outset the expert in that place.
No. But you need to place.
Therefore, that leads to product iteration.
Exactly.
Yeah. So it was in the magnetic sensor. yeah. That in the magnetic sensor space, I mean, that was it. It was a combination of it being from a technology perspective, it was the right complexity of product and the right demonstrator, if you like, validation technology, validation
Yeah.
product to show that the technology is real. We can do it in volume.
And was that something that was, if you don't mind me asking, just digging a little deeper here, was it the commercial team or individual coming back and saying, "Hey, why don't we try this?" Or was it technology saying, "We can do this.
Hmm.
Let's see if there's a market
It,
for it."
it's a little bit of both, to be honest. I mean,
Yeah,
I'd love
yeah,
to be able to
yeah.
say there was a pain point, we went out and
Yeah, yeah,
fixed
yeah,
it,
yeah,
and you
yeah,
do that
yeah,
sequential.
yeah.
There was a little
Sure.
bit of both because,
Yeah,
and that's going back to the point we said earlier about everyone sort of living close to each other, because those
mm,
directional decisions therefore become a bit of a melting pot of those different aspects. There's no point us seeing this market opportunity that is such a technological stretch that
yeah,
we're stretching too far. So it is a little bit of both, but there is, if you want to bias it one way, it has to be commercial first, because
yeah,
you don't want to, particularly with a disruptive tech, is when we talk about um, innovation and being disruptive, always on the positive side, right? That's always a good thing.
mm,
And on the whole, it is, right? Without us innovating disruptive technological steps, we won't make progress. But there's two sides to that coin. If you're too disruptive, if you're coming in with something which is either incredibly left field or very difficult to incorporate,
yeah,
then you may have bigger barriers to overcome to get your product,
yeah,
get your commercial traction.
absolutely.
And that's so you have to measure if you like, the level of disruption that you hit first. It's a journey towards
Yeah.
introducing something new, and you break it into those steps, not shoot for the difficult thing first.
It sounds like that level of coordination between, let's say, these 3 different areas, the tech, the engineering and scale up and the commercial are just so critical at the early stage.
Mm.
Do you and and that is unless you've got that coordination right and you've considered those different aspects, it's really hard to lay a big bet
Mm.
without knowing if you're going to A, be able to scale what you've got or find a market for it, or be that
Mm.
novel with the solution. So you've got to have those things answered for, it seems like,
Yeah,
before you really start motoring.
yeah, you do. And we had an added challenge in not 2D materials as a whole, but particularly graphene, with that sort of bit of an image problem before we came along. In that, that 20 years that I was talking about, a great number of companies, big companies, came into this, joined the bandwagon, came along into this market space and failed.
Yeah,
And not because the material itself didn't or doesn't have the promise and the capability to do it, but it was manufacturing issues, and uh, there was investments lost in companies that have just changed direction or wrote it off their roadmap.
sure.
So the importance for us was to, and the reason why the first product was so early, um, is that validation, that
Yeah,
credibility that we can, and customers and investors alike now are still ask come back to that question: how are you prepared? Are you for repeatability, scalability,
yeah,
manufacturing? Um, and that's how we differentiate. So um, that additional motivation that we had
yeah.
drove the early strategy too.
You had that, the dog barking behind you, or all of those failed graphene
Yeah,
companies.
yeah,
I think we may have worked with a couple of them
yeah.
over that period. So I remember that. Getting back to that validation point a little bit, how do you go about validating? What does the validation process look like for you guys? And here I'm talking really about the commercial piece. because they may say, well, look, I love the idea of enhanced performance for these magnetic sensors. That's great. But I need to have faith that you guys can do this at scale. And that's
Yeah.
kind of a classic chicken and egg. So, can you talk a little bit about what validation looked like for you guys?
Yeah. It's not that they could say that; they do say that.
Yeah, yeah,
I
yeah, yeah.
mean, and I suppose in the early days when the main markets were scientific sort of instrumentation, I guess you don't get that. I mean, if you're these days for markets, I said about quantum computing, for example, they're not that's not a huge volume market yet. So
Yeah.
people in that side are still it's all about the science and the
It is.
immediate performance, and the pressure of volume delivery is not there. But whether it again sticking with the magnetic sensing, I talked about that battery application. Now there we're dealing with a market which is firstly it's huge, and developing and moving very quickly. So the automotive industry's changed a lot in the last 5 years with the rapid emergence of electric vehicles, and whether that's a Tesla effect or the rapid pace that China is developing its automotive industry. But it means that when you're introducing that disruptive tech, certainly before 5 years ago, it would have been almost impossible. The big companies, the Volkswagens and the Fords, that this well-trodden, established new product development introduction process that takes years. There were no shortcuts. There's a whole
You've got to get in on the planning
hierarchy
cycles and so on, and
you
they're
get in
minimum
it,
5
and
years and all that. Yeah.
right, which for a startup is a challenge. EVs certainly shorten that a bit. There's a much faster development cycle time now, but it still comes to the same question. You come along as a scale up business, and they're really enthused by the initial samples. Then that question of how can you ramp and how quickly, and that they quickly talk about crazy numbers that you have to double check that there's not a decimal place missing somewhere. And you look at it and you go, well, you can't just blag it and say, yeah, of course we can do that. It's just scare us with the order, as you say. You have to back it up with something credible, and that is a sort of a challenge in the early stages, because hard tech, particularly building a fab, as we call it, a manufacturing plant for in a sort of semiconductor environment, is incredibly expensive.
Yeah.
And Paragraf's been very successful in raising investment to do that in the early stage. But even the money that we brought in goes so far, and we have to walk that balance between being able to install enough of a capacity to demonstrate at pilot scale and by that I'm talking about hundreds of thousands or million units a year. It's not small change.
Yeah.
But we can't go out and build a $200 million fab to demonstrate that we've got 5-10 years worth of capacity scaling done out. So you have to.
And are they saying anything to you
like?
Are they saying anything to you like, hey, look, if you build this at this scale, it will come. The business will come.
Yeah.
Or are they kind of holding back even more and saying, well, look, if you built it, then we know you're serious. Doesn't mean we're going to buy it. But
yeah, there's a little bit of both, and different partners, different customers have different appetite or requirements for that. It ultimately is down to confidence in in your ability to scale, but that there is the right product fit, and that your product makes it through their qualification and into the end device. And if you don't,
how long does that process
initial
take? How long does that qualification process take?
I mean, to get to in automotive, there's still, you're still looking at between sort of 4 or 5 years to get to the high volume stuff, but there's significant volume on the way, and that's the difference. Is that even in the 1 year in, 2 year in, 3 year in during the qualification phases, there are still challenging volumes in those stages too. So it's not a digital step where suddenly it goes from zero to tens of millions. There is a little bit of an opportunity for you to grow with it, albeit, pretty steep. And with semiconductor devices, when you're at the device level, and thankfully, die size is a relatively small number of devices you can get from a wafer is quite large. So the gearing is in your favor. If you make the right supply chain decisions and use outsourced partners for some of the non-core stuff, you can ramp quite quickly. And it's as much about credibility in that supply chain management and credibility in your ability as a business to manage an organization that's got that kind of production demand, and that you're not just the rabbit in the headlight scientist that is gonna doesn't know and never been in that position before.
Absolutely. What are those? When you're, for argument's sake, you've got automotive OEMs very interested, or tier 1, tier 2 suppliers very, very interested in what you've got, and they want to start talking about integrating your solutions into their products. And so you're having conversations with supply chain partners. What are the things that they are looking for? What do they want to? What's going to give them confidence that you're not just a group of zany scientists who've never even considered something like this? What needs to be in place?
You need to. I mean, there's the stuff I talked about earlier about our ability to be a credible manufacturer, but there's often a gap between the disruptive product that you've manufactured. Say in our case, this the magnetic sensor, and it's the same for the molecular sensor, which was the follow-on product that we now have out there. That you need to help the customer to know how to implement that product into their systems, and there's what my colleague Tom calls the implementation gap, which is that when that customer, whether it's a big corporate or not, they understand the product, they have tried a few and in their R&D environment, but then they have the challenge as to how does that product get incorporated into our product? What's the gap? How do we implement that? Because there's rarely such a thing as a drop-in replacement product, unless it's coming in at just at lower cost, or it has a better environmental footprint or whatever it might be. Then there are some cases where it's just a drop-in. But for most sort of innovative technology, there are associated developments that need to happen to around your core product to get yourself adopted. So, and what we've had to do is in some cases bridge that implementation gap to perhaps develop a little bit further around our own product that's not core. You've got to be careful that you don't go too far down that line and get swallowed up by it. But to for example, build an associated sort of or ASIC to go with a sensor, or to build a module that the sensor goes into, or to build some apparatus that allows you to demonstrate the performance of the sensor, that the customer doesn't have to work it out for themselves.
Yeah,
because then it can be that you can get a little bit of that sounds quite difficult. I'm interested, and I'll come back to it when I've got time.
Yeah.
So you've got to help them to make it. You've got to make it as easy for them to adopt as possible. And sometimes that means doing more than you originally intended to do in that market area at a demonstrator level, which then helps them bridge that gap, and then they can run with it. Once they start developing around your product, you're in. That's when you know that they've bitten, and the momentum really starts.
How much of that is extra kind of product development work or solution development work,
Mm.
and how much of it is really great communication, relationship development, management. Yeah, I don't know, education.
Certainly, yeah, we certainly had to have a lot more application engineering, if you like,
Yeah,
and things around software and
yeah,
in some cases sort of additional instrumentation and things like that, which we know, we had to bring people in that and work with partners to develop that exactly for that reason, for bridging that gap. Um, but you certainly need the close understanding of the customers' um, internal sort of dynamics as to how they bring a product to market and what to understand what they need, what the difficulty is, to make it as easy as possible for them.
yeah.
Not all companies are the same, but often they have the same internal challenges that you have. They're really excited by the technology. They want to find a route to get it into their product.
Mhm,
They've got budgets. They've got bosses that they need to convince, right? So
mhm.
you
Yep.
you build that face to face relationship with that customer, understand what they need, and help them on
Yeah,
that internal process within their business, because ultimately you've got a shared interest and a shared goal to
yeah.
get that technology into the market.
Are they looking at your scale up or manufacturing process as well? Is there a I've heard this from others, from clients and the like, but there can be issue with novelty in manufacturing processes,
Hmm.
because they're not
Yeah.
immediately accessible to others.
Yeah.
It's great they're
Yeah.
novel,
True.
whereas if you're going for something that's at least recognized and ideally modular as well, it helps with, integration if you need to do that later on, or it's just recognizable by other partners. Do you find that?
Yeah. Yeah. Absolutely. I mean that consideration is also one of the core, I suppose, principles or strategies that we've had within Paragraf to keep the manufacturing process as recognizable and as industry standard as possible. So while there is, closely guarded IP around
Yeah.
the process of manufacturing graphene, and it doesn't end at the graphene. Graphene's a single atomic layer of carbon, and trying to work with the materials around it to even put a
Mm.
metallic contact onto a single atomic layer is no mean feat. So there's a whole lot of IP and know-how around the process. But if you were to walk into um, our facility, which you should come down to Huntington, Chris, and see
Yep.
what
Yep.
we're doing with the new build. You'll recognize it as a semiconductor fab with the same kind of equipment in that you would see in a conventional silicon or compound
Yeah.
semiconductor facility.
Yeah.
And we've deliberately um, made that approach because I've tried to um, introduce novel processes to mainstream silicon industry for a long time, and um, the industry is, while it's incredibly innovative, is also very reserved about how it changes and what it adopts as a new material or a new process step. So if you can
Yeah.
de-risk that by having
Yeah.
recognizable tools, OEMs that they know,
Yes.
so that they don't have to completely rip out incredibly expensive tooling and bring in
Yeah.
something different. So we're able to give that confidence level to a degree, but we have to balance that between certainly keeping our IP very close.
Yeah.
And in the future, then there's clearly license models and things that we can use
Yeah.
to
Of course.
exploit further down the
Of course.
line. But you can only do that if you're industry compatible, that
Yeah.
you're not this
Yeah. Exactly.
crazy science
Exactly.
experiment in the corner.
Exactly. Exactly. Um, you and I have talked about this next question a bit,
Okay.
but how? What's it like trying to build this in the UK at the moment in 2024? You've done a lot of building of semiconductor facilities and operations in the UK in general for the last 25 years. Longer, I think. So what's it like doing that in 2024 with a company like Paragraf?
Yeah, it's challenging everywhere, right?
Yeah, it
It's
is. It is.
particularly challenging in at this time in the UK in terms of being able to. I said about how capital intensive, how expensive it is to set up a
Just out of
facility
interest,
like ours.
how expensive is it to fund a plant, a fab
Well,
for you guys? You know,
you
what's
know,
the rate?
it, to do, we're not doing everything in one go. What we're doing is building
Yeah.
a modular approach such that we
Yeah.
can build out at the rate that we can both afford and that the demand dictates. But our facility in Huntingdon is a 40,000 square foot building, and that's in the tens of millions of capital expenditure, over 50 million to do that, depending on the exact specifications and details of what goes in. But it's incredibly expensive, and now that's the same anywhere. That's not a UK problem. I
It
mean,
is. Yeah, exactly.
And all around the world we have that. You can see that the equipment cost is what it is. What we found that some of the cost difficulties and the rate at which we can expand is not necessarily around the expensive tooling that goes into the fab, but the fab itself. If you're spun out from a university and your software or somewhere which is predominantly desk based or small lab scale, you can go to an incubator into a science park, and the UK's got quite a few of that. Cambridge especially, right, has a great science park infrastructure which is built around that kind of sort of early stage. But we had to leapfrog that from the very beginning because the amount of footprint required, the type of facility that we needed, mean that you have to go out and find, in our case, a big empty shed, which was an old door factory in the outskirts of Cambridgeshire, which was gutted, and turn what was, famously, it was raining and snowing more on the inside of the building than it was on the outside when we first took it over. But create from the ground up something. The only thing we speculatively build in the UK is distribution warehouses, right? There's no ready-made factory, or you have to take on something that's either old and obsolete, or is not designed to be a factory, is designed to be FedEx or Amazon, which is so we've had to. Those sorts of facilities don't have the power that a semiconductor facility needs, doesn't have the infrastructure around it. So we've had to go through, don't start me on planning, but we've had to go through sort of various, what I feel are sort of UK related issues around getting the bureaucracy and the cost and the time around getting a local sort of electrical substation connected and power in the ground. And when you're venture capital backed, your investor doesn't want his money going into wires in the ground, right? They don't want to be building UK infrastructure. They want to see the technology. They want to invest in the product. So when your business model includes a significant amount of electricity, power networks and water treatment and things like that, for example, that's not a sexy investment for a lot of people.
But it's critical, because without good infrastructure, you can't do much.
So you see that when we look outside the UK, there's certainly support in the US, or recently I saw an example in Germany where there is government support for those kinds of infrastructure challenges that scale-up companies have, where we focus on what we're good at, which is the scaling the technology and getting the products to market. We've been good at attracting investment towards that, but we get some support to give us the footings to enable us to build upon. We're not expecting there to be a ready-made semiconductor fab sitting there empty for us to move into. I mean, that doesn't happen.
Yeah.
But
at least the base
you're able to
around it.
Yeah, exactly. Or if we identify somewhere that looks great, then some support to help us build that basic infrastructure to start from would be really helpful for accelerating our progress.
Yeah. What about talent?
I knew you were going to ask that, Chris. There's again, that's not just a UK problem, although we have got some sort of key shortages in key areas.
It's not, yeah.
In semiconductor electronics generally, take a look at what's happened in the US with the CHIPS Act, that building fabs certainly faster than they can staff them, and the skills talent shortage is recognized across Europe and the US as difficult, because and certainly in the UK, there's I look at it a bit like a lost generation in semiconductor manufacturing. That back in the 80s, 90s, when we had lots of facilities around Scotland and Wales and in particular, there was quite there were clusters and an ecosystem and skills, and people were relatively transferable, and you could put a record. We still got general sort of science and engineering people around, but there was nobody with that drop-in sort of semiconductor or electronics experience.
Yeah.
So we are recognizing that. I think in the UK there is the beginnings now of courses to bring people into the industry again, and it's starting to gain a little bit of momentum. But there is
specifically on the manufacturing, on the fab side. Not just on the design side, which we've had for a long time.
But I think that's covered. I'm a bit biased because I'm, but I think, you put semiconductor out all the time and you get chip designers.
Yeah.
And
sure.
That doesn't help with our end of the industry.
Yeah.
So those sort of and
it's also
hands-on manufacturing.
It feels like an integral piece. It feels like an integral piece for innovation in general, because it's what design is super important. But if you understand the process required to make,
we'd have to do our part.
Yeah,
we do our part in terms of trying to bringing that new and certainly younger scientists and engineers through. We're doing, for our size, we're doing a sort of a disproportionate amount of internships and starting now with more apprenticeships and things like that, which is we found incredibly valuable. We pulled in interns from the US and MIT and so on, who have come over to Cambridge and worked with us for either a summer or in some cases for a 12-month placement.
Mm-hmm.
But that's an investment that's going to take time to pull through.
Absolutely.
And certainly there's a much better, more diverse workforce coming through at the younger ages now. But again, that's taking time to make it up into the more senior, experienced positions. But we're getting there.
Yeah. If to manage that, do you? And this isn't just a question for you guys necessarily, but should companies be considering broadening their manufacturing base beyond just the UK, to the US, to Europe, to Asia, in order to meet the demands now?
I think the international scaling is important. I think Paragraf's position is that we want to stay in the UK and building a company in the UK while those sort of attractive conditions exist. It's without doubt there are in other regions incredibly enticing conditions, be it initial incentives, but you have to operate in a country beyond those initial incentives. The help to set up is really valuable, but you're at the end you're still left with a factory you have to operate in that place. So there are other considerations too. But I think where we see the future going is certainly remaining UK biased, but we also need to look at where our customer base is, where the right partnerships are, and as we move into higher volume markets in automotive or other related industries, then
yes,
it may well be that we have other locations in the US or Europe that complement that. So we set up Paragraf USA quite early on. Made an acquisition in San Diego, which is acting as our first sort of modest footprint in the US. But already through that, we see there's an attractive business environment out there, which is working at the moment, complementary to what we're doing in the UK.
Yeah. One final question, Tony, if I may. You've had a great career, a long career in the industry.
It's not over yet, Chris.
It's not. It's definitely not over. But if you were to stop and think about some of the really big lessons you've learned that you'd like to see applied more or wrapped into the thinking, particularly for these types of businesses as they're setting up, what might they be?
Well, I think I probably touched on the points we talked about earlier. I think because even in the last few years in the Paragraf environment, I've learned lessons in what's important in this scale up sort of lab to production journey. And we talked earlier about that, getting that market product knowledge and credibility with those customers. That was certainly a very quick lesson within that environment for us at the beginning, is to make sure that you are able to be an authority in that market and talk directly to the experts and not come in as an interesting science that doesn't really understand the market, doesn't really understand the product. You've got to be able to answer questions directly and understand their pain points and be credible in front of the customers. So for any startup, scale up business, that if you have to bring it in, then do so. Bring in that market expertise early. It will short circuit a lot of revision of your product and development time of your product to meet the customer's requirements. I'd say the other lesson was that, again, repeating what I said before, that implementation gap idea. Be prepared to have to develop around your core product to help your customer implement your technology. Don't expect them to do all the legwork for you. Help them to get your product to market, because you're on that journey with them and you share a mutual benefit in being successful. Don't just expect them to work it out on their own. You've
got to be budgeting for that. That's part of the whole
absolutely
thing.
Yeah. Cost size, resource wise, it's different expertise. So you do have to think about that. I think finally, probably from a practical perspective, when you're physically building the company and the infrastructure, and that's to make sure you design in flexibility in your capability going forward. Building a factory, building a fab, ordering equipment, buying in long lead items. The time scale involved in doing that is longer. It's a slower heartbeat than the way the technology is moving.
Yeah.
So you don't design a facility or a factory or a capability around what you think you need today. Build in some flexibility in that. Don't underestimate the ability of the scientist to completely turn a process on its head within 3 months and to define a whole new way of doing something which is much better. and that stuff I've put in place that I ordered 6 months ago, we don't need it anymore.
Yeah.
So you have to be flexible with that, and be prepared for some sort of changes of direction, not just when that happens in your strategy or your product development, that rolls down into your facility and your factory and your and the practical infrastructure that you need. So being prepared for that potential change in the detail, when there's big money involved, you don't want to be building something which is obsolete before it's finished. So consider try and predict the unknown when you're building the factory as well.
I have to ask, I can't let this hang. How do you build in that flexibility? Like, do you create contracts where you can give it back or
Well,
undo what you've done if you've already
yeah,
started building?
equipment manufacturers are not great at the return model.
Yeah, I
No,
think so.
no, but luckily, I think that you don't want to become. It fits with the strategy I said earlier about not being too sort of specialist or
Yeah,
wacky in your
I see
manufacturing
what you're saying.
process.
Yeah, I get what you
Is
mean. Yeah,
make the tools as relatively generic as you can, such that
yeah,
if you can make process changes, use different materials, chemicals, such that the changes are in the recipe, not
I get it.
too much in the throw the tool out and buy a new one.
I get it. I
Um,
get it. I get it. Yeah, that makes sense.
that's it. But sometimes when you're trying to keep to a budget, you strip out all that stuff and you go, I only needed to do that, so I'm only going to buy it to do that. And then when the process
Yeah,
changes, it doesn't do
yeah,
anything else. So sometimes it involves just having a little eye to the future.
I get it. I get it. Tony, amazing. Thank you so much. This has been great. A nice deep dive into thinking how you have a chance of taking one of these things from kind of very early doors through to something that's far more mature. This has been wonderful. So thank you so much for joining us.
Thank you, Chris. It's been a pleasure.
You've been listening to the Lab to Market Leadership Podcast, brought to you by Deep Tech Leaders. This podcast has been produced by Bauhaus. You can find out more about us on LinkedIn, Spotify, Apple, or wherever you get your podcasts.